plane stress condition is the one condition in which stress component acting in a plane. Okay. So here, if the stress is acting out of the plane, okay, we assume that stress which is acting out of the plane is zero. Okay. So it is the state of stress condition. So it is a state of stress condition in which normal stress which is acting along that outer plane, shear stress also acting out of plane, okay, is zero. Now, for example, if you have body, okay, in real life we will have a three-dimensional body, okay, but in that three-dimensional body there can be a condition in which that our force or stress in that body is applied in a plane. Okay, so since this is a plate, if the body, if the 3D body is very thin, okay, the 3D body is very thin, in that case, okay, in that case our stress conditions, if the 3D body is very thin and the load, applied load is also acting in a plane, okay, so in that case what will happen, in that case, for example, this is your x-axis, this is your y-axis, and this is your z-axis. Okay, the body is thin and force also acting in a plane. In that case, stress conditions that is acting here also will be in plane stress. Okay, the component of in plane stress will be is significantly higher than that stress acting in the z-axis. Okay, okay, or in the z plane. Okay, so here we have that x-axis, this is y-axis, and this is z-axis, and this is thin plate, and we are applying the force acting here in the direction of x or in the direction of y. Okay, that stress conditions will be such that that force condition, or you can say it will be such that that also acting in a plane. Okay, if the force condition also in a plane, in that case what of the stress will be there, the stress that will generate here in the body also will be in plane in nature. Okay, so here stress condition will be here sigma x, sigma y, or xx, sigma yy, and the tau xy. These three components will be predominantly higher than the component which is acting out of plane. Okay, so here since that stress which is acting out of plane is significantly lower, we used to consider as a zero. Okay, so basically state of plane state of stress is one condition in which we will have stress condition which is acting in a one particular plane. Okay, and out of the plane stress condition, out of the plane stresses are assumed as zero. Okay, I hope the idea is clear now. Okay, so let us discuss that how that your matrix look like, how you can write mathematically the plane stress conditions. Okay, here you can see this first equation here basically is known equation where we have a body. Okay, we have a body and we are applying some force here, and due to the force stress is developing and strain also developing. We already know that sigma, the stress, is proportional to strain, and from that we can write the stress is equal to E into epsilon. Okay, now if you consider the Poisson's effect in that case, okay, if you consider the Poisson effects in that case, our strain conditions, okay, also depend upon that basically it is acting the other two direction. Okay, so for example, if you have body and we have force acting in all the three direction, then strain condition can be taken in this direction. Okay, strain condition for x direction, similarly strain condition for y direction, strain for z direction, and this is the relationship for the our shearing strain gamma, shearing stress xz, shearing strain xy. Okay, now if we try to write this individual equation in a matrix form, then this equation can be written in this way. So here you can see that epsilon xx, that is equal to sigma x by E minus sigma yy mu sigma y by A minus mu sigma z by A, and we multiple here, it will be 0. Okay, so basically this first equation is corresponding to the here, second this one is corresponding to this equation, and third one is corresponding to third equations, and similarly this is for fourth, this is for fifth, and this is for your sixth equation. Okay, now we'll come to our plane stress condition. So these conditions here, okay, this condition here you can say that it generalize our relationship between the strain and the stress. Okay, now if you consider the plane stress conditions, already have discussed that plane stress conditions, out of plane stresses are 0. These three are 0. Okay, if three conditions are 0, then what we can do, we can again try to shortcut it. We can try to reduce the number of basically unknown here, because this value already known to us, we are putting the 0. Now if we write this same thing, what will happen, our strain condition can be written in this form. Okay, you can see this equation, this is 0, so basically we will have sigma xx by E minus mu sigma yy by E, so z term is 0, so not come this equation. Okay, so now our individual equation for strain along sigma xx, strain along x, that is the epsilon xx, epsilon yy, epsilon z, and gamma xy. Okay, now here you just see, here we just see in a plane stress conditions. Okay, in a plane stress condition, we will have the stress which is acting in plane sigma xx, sigma yy, and sigma, or you can say tau xy. Okay, but the strain condition along the z direction will not be 0. Okay, so though it is plane stress condition, strain, out of plane strain will be there. Though it is plane stress conditions, here you can see we are putting that stress condition as 0. Okay, but here this is strain part will not be 0. Here you can see that epsilon zz, that is equal to minus mu sigma xx by E and mu sigma y by E. Okay, so these conditions will be there. Okay, since load is applying along x, so now from that we will have a, due to the Poisson effect, we will have a strain along the z direction. Okay, so now we'll have these four equations. Now these four equations we have. Now if we try to write in matrix form, okay, again if we try to write in matrix form, we can write that our plane stress condition in that format. Okay, so epsilon xx, epsilon yy, gamma xy, written 1 by E, 1 minus mu 1, 0, 0, and 2 into 1 plus mu. Okay, right side there will be our stress condition for the plane stress, and we'll have our basically out of plane strain condition here. Okay, now if you invert it, then again that plane stress condition can be written in this form. Okay, some book will observe that some book write the equation in this format, some book write in terms of stress. In that case, we have to write E 1 plus mu 1 minus mu, okay, 1 mu 0 mu 1 0, and 1 minus mu by 2. Okay, this side we will have our strain which is acting in the plane, and again here you have to write the strain condition acting in the z. So now here you have to keep one thing in your mind. In a plane stress condition, we'll have the stress which is acting in a plane, and we'll have strain which is acting out of the plane. Okay, so now if somebody asks you if the condition is plane stress condition, can it be the strain out of plane, then your answer will be yes. So to the Poisson effect, we will have a strain in the z direction. Okay, so I hope you get some idea. Thank you.